talking about R today. I put up some links. These are some of the best things to a couple of links to R. Something I'm going to show off. A couple of good books, a couple of some places to find out more. So if you want to look a bit more, then you can go there. I hope it doesn't look too funny on the. Oh, sorry. So R is. How many people here use Excel? Yeah, everyone knows Excel. How many? Anybody use R? A couple people, yeah. Well, R is it's a programming language and a system and environment for doing statistics and dealing with data and doing graphics. And I'm not a statistician, and I haven't done a lot of programming in R, but it's really good for getting into data and doing graphics. And I'll show 3 examples of that to show what it's looking like and try to give you a sense of what it's like. Because if you've ever been doing something, say, at a command line, or you're using some Ruby or Python or something that an interpreted shell, and then you need to do something with some data, so you go over to Excel, and you're all pointing and clicking, and it's all dragging, and you think, I would like to be able to deal with all this data the way that I deal with everything else, where just some text commands, so I can do stuff like that. Then R is a system that you can use to do that. So I've got a couple of sets of data. The Toronto Public Library posts some of their stats and circulation stats and things online. So I'm going to load in sorry, I want to import these text file. There's a heading on it. So if you want dealing with the comma-separated value files, it's just one command to read in a CSV file, and then it parses apart the structure of it there. And you can see up here TPL, and it gives you a column for the year, a column for the number of circulation, the number of visits. Preschool children, teen and older are the number of people that attended some of the programs on offer for kids. You can look at the data here in the console down at the bottom. Type in TPL, and it shows you the data structure right there. If you want to pick up one particular column, TPL visits, those are all the visits displayed as an array. If you want to see one particular row, it'll show you one particular row. So you're sort of slicing apart things there. You've got all of the, if you want to see, also the TPL $ visits is picking apart one column of that. If you want to divide an entire column of things by, say, the first element in that in there, you can just divide, and everything all sort of works out. You can see here, if you want to look at how the visits to TPL have been changing, as a ratio, and they've sort of gone down to like 0.9, or they're up to 0.99 there. This is a bit about, well, so you can deal with stuff in a console like that, look at numbers, but you also want to visualize some things. You can do give a bar plot command for a set of data, and it pops up a little a bar chart there. If you want to just do a line plot, pops that up there. And it does its best that it can with figuring out stuff to go along here, stuff to go along there. You can customize all of that completely if you want. I'll show you. All right, yeah, so this, let's look at the here's a graph of the circulation that's been going on at the Toronto Public Library system. Something was around, back there it was around 28 million, and it seems to be generally going up. With this index, it should be showing stuff by years along here. What we've actually got is a time series. So let's specify, tell it that it's a time series. Now it's showing us the years down here. Kind of neat. You're like controlling this graph dynamically as you're doing things. We can turn off all the axes and all the annotation and just have the dots there. You can specify that you want to draw with points, which is what it was doing by default. You can say type equals L, and it'll draw it with lines like that. Or you can say type equals B, draw it with both like that. Let's say that we want to go back, draw it with points like that, but we want to kind of do some more with what's going on the axes and the labels. I'm actually going to paste something in here. I'm just going to paste this in to save time. There, so I'm saying do a time series showing years along the x-axis, circulation up the y-axis, draw points. Don't show any of the axes because I'm going to put them in later. Put a label on the y-axis of this, a label on the x-axis of that. Put a big label at the top there. And these things are starting to come together. I can paste in there. There's an axis command. The first argument there, 1, means we're dealing with the x-axis. So I've pasted in all of the years, but I made them go this way for readability. I can put a box around it. I'm going to paste in a couple more things that do stuff on the y-axis. I'm just setting something up. There, so now I've said show me everything on the y-axis in millions, but make the numbers look that way. I'm not going to show all of the zeros, just putting 28, 29, 30. So there's something sort of, you can customize, move things around, have some more space around the edges. Sort of seems to be going up. Maybe you want to do some linear regression on this. You want to see what sort of a line you've got. If you, I'll say circulation per year, I'll make a linear model. We'll do circulation against the year with a data set of TBL. So I've done, I've made this this model, and now I will show it. AB line means display this line, and you can see how the circulation per year over there is changing. But it's the thing I like about dealing with R. I mean, you can do all this in Excel probably. Well, I'm sure you can, but doing stuff, typing in commands, being able to change the graph as it's going, add things in, take things out, reshape stuff, see it as it's doing. It's much like being, well, you're at a console shell there, and this dealing with the text, you've got there's much more commandless, dragging and pointing and putting up with Microsoft. The next, or loaded another data set. This is based on something that I posted about on my website a bit, so I apologize if it seems familiar. The ARL, the Association of Research Libraries, keeps track of statistics for all their members all around North America, and it's going to show up there. So I collected all the data, kind of munched it all together. The data that they had up available on the website was kind of messy. You could clean it up inside R if you wanted, but it's much easier to clean it up in something like Perl or Ruby or Python or something like that. That's where you're dealing with text. In the ARL's files, they had some of the stuff that they recorded, how much people spend on serials, how much they spend on monographs, how much the salaries are, and sometimes they actually have money numbers formatted with a $ sign and some commas in it, which you don't want when you're dealing with numbers. You just want the thing as an integer, not a string. So I cleaned it all up, made it into a CSV file. Here it is. It tells you, you got lots of columns there for each year. That INAM up there is the institution name, the name of the university. Tells you various things about the university. If you go over, there's stuff about the holdings. SER, the prefix there, it's for serial. If you get over a little more, PRF staff is a number of professional staff. There's things about expenses, and over at the end, TOTE-STU is the total number of students at the institution, and faculty is the total number of faculty at the institution. Big, huge data set. As it says there, there's 2,300 rows that are in there. There are about, I forget how many ARL members there are, but there are dozens. So there's a thing, there's a library you can use called Lattice. It's really good for comparing lots of sets of things in different ways. I'm going to do a couple of things. I'm going to load it in. I'm also going to paste in something. I'm going to make a subset. Out of all the ARL members, we're going to make a little subset that I'll call compare. So I've got this that little arrow sign is filling up a compare with all the output of this subset command. I'm picking out all of those institutions from this big ARL set. Is there anyone here who's a member at an ARL institution that isn't in that list? We've got like Western, York, Toronto, Queens. I'll add in Queens. There. I'm going to do this, and then I will PRF STF. It's here. So this command is saying, make that bigger. You can just rerun that there. So this is XY. This is what. Ooh, let me rerun that. Is that going to look better? That looks a little better. So lattice graphics are a way of showing lots of things going on at the same time. That over there you can see we've got fact over PRS FTS. So it's showing the ratio of faculty to professional staff. The little tilde means show it by each year. This is the ratio here, 10/25 of faculty to professional staff. Year, you can see 1990 up to the 2000s. 1990 to the 2000s indicated up there. And that bar INAM means break it up by institution name. Divide it up based on the institution name, and that data equals compare means take it out of this comparison subset that I made. So you can kind of see, if you're looking at faculty to librarian ratios, and all these different institutions, you see that there's where I work. We're up around 28 or something like that. Some of them we're staying about the same. McMaster is jumped around. Brown, look, Harvard, extremely low. I mean, they've got lots of, that is an extremely good ratio. There are other numbers in there. We could look at the ratio of total students to faculty. Where I work, one of the worst ratios there. That is, there's Western going along, jumping up again. Stuff like Harvard. Harvard's ratio seems to be going down, getting better and better. Ours is getting worse and worse. Southern California, USC jump. Look at, so Yale, extremely good. York's got the worst. If you look at the ratio of total students to professional staff, you get a similar looking sort of thing. Again, you get the sense that maybe with R, you've got this big data set, and you think, well, what's in there? What if I divide this by this and look at it over here? Do a command, change a variable, look at that, change another variable. You can just kind of play around. It's dead easy, new stuff appearing, gives you good visual indication of what's there. Here we are with the student to librarian ratio. York, again, the worst. Here's master there, somewhat better. The big, rich American universities are extremely good. This, I'm just showing the dots here, but you might use, there are other ways you could format this. You could say type equals, if we want to do some regression, I can add in this type thing that I've added in here. This in R, when you put if you want to make an array of things, and you use a C to sort of make passive, make an array of things. I'm saying show this XY plot. The P means show points. The R means show the regression. So now it's put in this line on top of things. And if you want to kind of simplify it and just see what it looks like as trends, then you can just show the regression and just kind of boil it down to the lines. So you've got this big data set, a few commands, and if you boil it down to this, showing the essential essence of how stuff is either getting better or worse with student to librarian ratios at your university. And say, at York, I know the university librarian has sometimes taken this kind of thing in to show, and she is making a justification for why she needs more staff. You see something like that, that does not look good. And you can compare it to other similar institutions and show just how, in fact, how bad the situation is up at York, which we would all like to make much better. The third example is, none of this is really getting into any of the serious statistics because I don't know much. I don't know anything about statistics, so I'm not even going to get into that. There is a guy named Georges Manette, who is a stats prof at York, who wrote a library for doing a library that builds on top of the interactive 3D visualizations that you can do in R. And I will load in that. Just for fun, though, I'm going to actually do it in Emacs. Minimize that. So normally, if you just go and download R, it runs at the command line. And the command to run it is a big, just capital R. You run that, and then you find yourself sitting at a command line. This that I was running is RStudio. If you're gonna go try R, then I'd say install RStudio, start poking around using it. It makes it really easy to load things in, do the visualizations. However, just to show you something, and because I want to do some more cutting and pasting, I'm going to use the Emacs mode for R, because I want to show a couple of things at once. I'm going to load in a library. There's a thing called CRAN, which is to R what CPAN is to Perl. There's a package management system where you can just install this package, it'll go take care of all the dependencies, install everything for you. P3D is the thing that Georges Manette did. I'm going to read in I read in a bunch of data, showing that doing a head on the data. It shows the first few lines. What this is some demographic and health information. You've got countries, you know what continent they're on. LE is the life expectancy for the country. Cigarette consumption is the number of cigarettes smoked. Health XPC is the health expenditure per year in that country. I'm going to popped up this little window over here. Now I'm going to run plot 3D. I'm going to show life expectancy again and cigarette consumption. XPC by continent. Oh, I'll put on some. So, got that. This is a manipulable three-dimensional object. So you've got the thing there. I'd like to add some axes. We'll run the axes command, axes 3D. Now the axes have appeared there. You've got three things: life expectancy, cigarette consumption, and health expenditure per capita. If you look at it, you can zoom it all around. You can zoom in and out. Let's look at it along one axis and look at life expectancy against cigarette consumption. Seems to show that the more cigarettes you smoke, the longer you live. Does it maybe show that the longer you live, the more chance you have to smoke cigarettes, so your cigarette consumption is higher? There are correlations, not like causation. So there's something going on, and you could dig into it more. You can rotate the thing around to show what it looks like if you just show, looking along this axis, life expectancy versus against health expenditures per capita. What this shows is that for a really, really small increase in health expenditures, life expectancy goes up really, really quickly. Then it plateaus, and the more money you spend, it doesn't make much of a difference. These are African countries. Up here, lots of European countries. The thing that Georges Manet was doing would let you select one of these dots, and it would tell you what the country is. Because of something I did, I seem to have messed that up, and it doesn't work. If I didn't have time to reinstall things fresh last night, this should show. Those are all European ones along there, and that is the United States, which spends more than anybody, but whose average life expectancy is not as high as some other countries that spend less. So the two things about R, it's dealing with stuff at RStudio through the command line is a wonderful way of dealing with stuff, and it gives you this sort of text-based, command-based access and a huge sense of data that it's easy to manipulate and play around with in a really fun way. Also, as if you wanted to learn it, if you there are a couple of good O'Reilly books. There are lots of books about R, lots of books about learning statistics with R, doing visualization with R. This is good one, lots of interesting examples and good coverage of all of it. And when you get into it, you'll find too that when people there are a lot of questions that get asked, that get answered on Stack Overflow or places like that. And lots of people will be posting code snippets and links to the data file they were working with. So someone might post a nifty 3D visualization of something, and they would give 8 lines of R, they would do it, and you could just paste them into your thing, and it works. And then you can look at it a little closer, load in your own data, look at this library that they've got, how they're using it, change some things around, and hack it and tweak it. So you can end up with something really beautiful, even though you're not quite sure what's going on, and you've just kind of left the magic up to somebody else. So I recommend it. I highly recommend trying it out. It's if you've only ever been hearing about it, it might seem a little forbidding, but it's quite approachable and a really, really good tool to use. Thanks.
Any questions?
Bill, I'm curious if you know anything about whether there's any front-end packages or web-based APIs for serving the diagrams or graphs programmatically across the web. Like if you could build some kind of application where you could pipe the data to it, get an image returned to you over web services. Has anybody done something like that?
The RStudio runs in a server mode, and you can talk to it over the web. What it gives back, I'm not sure. There are front ends to it in Perl, Python, and Ruby, so